Hi guys, I'm Meena. I'm currently studying in Sri Venkateshwara College of Engineering. So today's topic is about Prim's algorithm. So Prim's algorithm is a greedy algorithm that finds the minimum cost of a weighted as well as in an undirected graph. It is used in various applications from network optimization to circuit design. And coming to minimum spanning tree. It is a tree that connects all the vertices in a graph with the minimum possible total edge weight. And coming to the properties of minimum spanning tree, it says that it should visit all the vertices without forming a cycle, and it should contain the lowest possible weight among all spanning vertices. Next is overview of Prim's algorithm. First is greedy approach. Prim's algorithm uses a greedy approach, always choosing the edge with the least weight that connects a vertex in the tree to a vertex outside the tree. And second is minimum weight edge. At each step, the algorithm selects the minimum weight edge that connects a vertex in the current tree to the vertex not yet in the tree. And third is spanning tree. The algorithm continues until all the vertices are connected, resulting in a minimum spanning tree. And here's the step-by-step explanation of spanning tree. First, we have to initialize them. We should start with an empty tree, choose an arbitrary vertex as the starting vertex, and next step would be edge selection. Under edge selection, we'll be finding the minimum weight edge connecting a vertex in the tree to a vertex outside the tree. And third is tree expansion. Add the chosen edge and its connected vertex to the tree. And fourth is iteration. Repeat step 2 and step 3 until all the vertices are connected. Next is Prim's algorithm, how it actually works. Prim's algorithm, it is a step-by-step process for finding the minimum spanning tree in the weighted undirected graph. And coming to greedy approach, the algorithm says uses a greedy approach, always choosing the edge with the least weight that connects a vertex in the tree to a vertex outside the tree. And next is minimum spanning tree. The algorithm continues until all the vertices are connected, resulting in a minimum spanning tree with the lowest possible weight. So this is the example of Prim's algorithm. This is the spanning tree where we have to find the minimum cost among this. So let's consider A as the source node, and let's check by considering the other rest four nodes connected to A and their weights. So A to B is 4, and A to C is 6, and A to D is 6, and A to E is 5. So among this, the least one is A to B, which weights 4. So at the step 1, I'll connect A as the source node and then B as the current node, and it weights with the minimum cost, that is 4. And now by considering the source node as well as the current node, I have to visit another node which is having the least value. So for visiting the other nodes, I have to follow the three rules. The first one is that I have to visit all the nodes. Second is that with the minimum cost only, I have to visit all the nodes. And the third is that I shouldn't form any cycles in this. So now if I'll consider B and check how many nodes are connected to B. So for B, E is connected and then C is connected. Among these two, the lowest value is C. So I'll connect uh, A as the source node and B as the intermediate node and C as the current node with the minimum cost from the source to the destination to the current node. I can visit with 6 as the weight. And now from C, I have to check which is the lowest weight where I can visit. Mm, So for the C, E is connected and D is connected, and A is also connected. But when I place A to C to A, then it forms a cycle, and also it is having the higher weight. So I will not consider that. Instead, I'll consider C to D. So C to D has 1. And now coming to the node D. And now I'll check the least minimum weight. Now D to E is 7 and D to A is 6. So here comes the problem. Now, as I told, from the source till I have to visit all the node with only the least value. Now, if I visit A to E and then E to D, it costs me more. So what I do is I'll visit A to B, B to C, and C to D. And here I can check that B can also visit E. And also C can also visit E. Now I'll consider among these two the lowest value, that is B visits E. Here I'll consider A as the source node and then B as a second node, and then I'll visit C and D, and then I'll come back. As it is undirected graph, I can go back. So I'll go to B and then I will check the minimum cost and I'll connect it to E. And now this is how we'll find the minimum weight for all the adjacent matrices. Now when I add up all the weights, the value will be 10. Now let's learn the time complexity of Prim's algorithm. For the adjacency matrix, the time complexity is O of V square, where V is the number of vertices. And for the adjacency matrix, the time complexity is big O of E log V, where E is the number of edges and V is the number of vertices. In comparison to Kruskal's algorithm, prims are efficient for dense graph and requires a priority queue. Under Kruskal's algorithm, the efficient for the sparse graphs uses a disjoint set data structure. And then applications of Prim's algorithm. First one is the networking routing, finding the most efficient way to connect all the nodes in a network. And second is circuit design, connecting the components in a circuit with the minimum wire length. And third is transportation network, optimizing routes for the public transportation systems. And conclusion and the key takeaways about Prim's algorithm is that it is a powerful tool for finding the minimum spanning trees in the graph. It's widely applicable and offers a practical solution for various optimization problems. So this is all about Prim's algorithm, and thank you for watching.